Okay, thank you, and thank you to Michael for the invitation to speak here today. It's great to see so many people here interested in the bioenergy area. I've been working in bioenergy now for probably longer than I care to remember. The first half of my career I spent in the commercial sector. I did my fair share when the UK was putting in its first waste and biomass plants, working as a combustion engineer, crawling around inside boilers, trying to work out what was going on, and really being frustrated that there was a lack of knowledge exchange from what people knew in academia and what they weren't telling us about, you know, the fuel properties and what was actually going on and where we were losing money in the commercial sector at that point. I then moved over a little bit and I ended up working for a long time as a technical advisor to many of the big banks and financing institutions in this space. And as part of that, I was appointed to a ministerial advisory board a very long time ago, when we were really looking at the early years of renewables obligation implementation in the UK, and I sat on the Finance and Investment Working Group there, where we were helping out with a lot of what happened in the adjustments in the early years of the RO as we transitioned from the previous NUFO arrangements. So for me, in order to make bioenergy happen, there's a number of things you have to get right. You have to get the technology right, because I felt the frustration of plants that don't work, believe me. You also have to get the environmental objectives right, and the policy has to come in and actually really support that. So those three things need to come together. And nowadays I lead a group in the UK called the Supergen Bioenergy Hub. This brings together academics, industry and policy to focus on sustainable bioenergy systems, because I think it's only by bringing those three together that you can actually get anywhere with this. So I'm going to show you, at the moment, the hub has, I think there's 19 on there, academic partners up and down the UK. So all of these people between them are carrying out £12.8 million worth of research in bioenergy. Okay, this is all ongoing at the moment. And these are our non-academic partners. They significantly outnumber the academic ones, and you'll see some people you would expect on the policy side and on the big players like Drax and Eon and others in there, but also a lot of small companies, because the bioenergy area is also incredibly fragmented. And this is one of the reasons that knowledge exchange and growth of the industry is very hard, because we have some very small players and some very big ones, and there are a lot of commercial sensitivities about what people are doing, and trying to get to a place where we're all actually implementing things that are sustainable and moving forward to some of these targets we're looking at is quite a challenge. We do have a stand here today just around the corner where you can get lots of information on the whole variety of research that this group is carrying out. One thing I was particularly struck by this morning was the focus on emissions. We have loads of work going on in emissions, but on a whole variety of issues. Cara particularly mentioned life cycle assessment. I spend an awful lot of my time on greenhouse gas balances for bioenergy. I sit in a climate change centre. I couldn't, countenance doing stuff and promoting stuff that wasn't making a difference in terms of climate change. So that's really, really important to me, and I have chapter and verse in terms of books and reports on that round there. So I'll show you the web address at the end, but come round and talk to us. There's a myriad of boring reports, but we can help you to get to the right one for whichever issues you're trying to address. Okay, so now on to the main bit that we're supposed to be talking about. That was the intro. Policy and bioenergy. You'll all be aware that the policy landscape for bioenergy stretches from the global with the IPCC, UNFCCC frameworks, down to the European level, national frameworks. In the UK, we've been going for a long time in this. I'm old enough to remember the predecessor to all of these. I took some projects through on the non-fossil fuel obligation, which preceded the renewables obligation. And we've had a number of adjustments and implementations over the years. It often feels like we sit in rooms in London having the same conversation again with the next minister, the new person, and you can feel my frustration in this. How many times do we need to tell you the same thing? This can make a difference. We need security and stability, and we need to get on with it. But I think, to be fair, I think it was Cara again who mentioned it was Matthew who mentioned the Searchinger report. There has been a lot of uncertainty that we've brought on ourselves here. The carbon neutrality thing has been mentioned once already this morning, and 10, 15 years ago, we were telling people that bioenergy was carbon neutral. Simple, end of. But that wasn't quite true. And then we get round to the intricacies of it. And we therefore have ended up with, as we've gradually uncovered more things, we've introduced more complications along the way. And I think it's right in some ways that the policy should stop and should try to take account of this. And one of the reasons we've had so many changes is we've had constant updating of policy mechanisms trying to catch up with where the science is, and where we try to say, what we really do know and what we're certain about and what we're not hasn't always been terribly well communicated to the people who are making the policy in advance. Now, it sounds like, from what I've heard this morning, you're just about in time to try and sort some of this out with the RHI implementation, but I'll come back to that a little later because I have some information here from the UK's RHI, which I think you'll find of interest. So, if I were to have completed the questionnaire that Cara sent out, saying, why she was sending it to farmers, saying, why are you not doing this? If I look at in the UK today, and indeed for most of Europe, as to what are the challenges that prevent us from putting good policies in place that will support bioenergy, number one, top of my list is uncertainty. And I've talked about the scientific uncertainty. I'm going to show a few more examples of that in a moment. The second is boundaries, and this has been touched on already, that we have the energy system, but there's also the land use, the agriculture, the food. All of this actually plays into bioenergy, and that makes it just that bit more complicated than wind or solar PV. Land is massive within that, the food security balance issues, that's really, really important. And all of that leads to interface issues. And what that means is that you can do a certain amount with energy policy, but you might find that you're still not hitting the right buttons to make bioenergy move forward. Timing of emissions is something that has been raised in recent years as an issue, and I'll talk about this a little bit later. But the last one I want to bring in is this idea of carbon neutrality and biogenic and fossil fuel distinctions, which I think has been overrated a bit, but I'll come back to that. Okay, uncertainty. This is some work which we did in the Tyndall Centre looking at forest residues for electricity. I'll try and keep this simple. The black line is the carbon intensity of electricity from coal, and what you can see is a number of different cases of ways of bringing forest residues and sawmill residues to electricity plants in the UK and looking at their carbon intensity. If I move through this, what you see is that on the left-hand side of each of these cases, you have a bar which equates to having no storage of the chips which are being used, the residue piles. And as we move through, you will see that the emissions intensity increases the longer that you store this material, to the extent that within 4 months, you have completely negated all of your carbon savings. Now that looks quite scary, if you believe it. Because this is all predicated, and this happens so often with life cycle analysis and uncertainty, this is predicated on one number. It's the releases that you get in piles of wood chips of methane and N2O to some extent, but mostly methane, while it's being stored. What you will find, if you look in depth at this report and others like it, is that often they all go back to the same source. Most people reference one reference which was done back in the 1980s by one person with one pile of wood chips in one place, and everybody uses the same number. They don't take into account the experimental error, they don't take into account the variation. So you've got to be really careful with this sort of stuff when you bandy it around. And believe me, we have the paper over there, you can check. I have been very careful, and we have examined the sensitivity on this. But it shows the potential to get things very badly wrong when you don't know what you're dealing with. And that tells me that if we want to do sensible things with bioenergy for climate change, we need to remove as many of these sources of uncertainty as we can. And if you're putting a policy mechanism in place, you need to be able to adapt as you get new information and you sort out some of these uncertainty issues. Here's another example. You won't find this published anywhere. This is work that we did last year for the Department of Energy and Climate Change in the UK. They wanted us to look at the renewable heat incentive in the UK, and they said, how much greenhouse gas emissions are we really saving for different case studies? We completed this work last summer. It was then audited by DEC. It went through their auditors, we addressed all the comments. It's been sitting on someone's desk now since November. It has not yet been published, but I'm going to show 2 slides from it to you today. If you're interested in seeing the whole thing, please let me know and I will get it to you as soon as it is published. But here are the key things. I have a number of different cases here, particularly focused on cattle slurry and AD. We did lots of cases, this is one of them. And this is heat for bioenergy, and what you will see right up the top, that purple dotted line, is the natural gas carbon intensity of heat in the UK. The red line below it is the carbon intensity which is being proposed as the sustainability threshold for the UK's RHI. You will see a number of different pathways as you go along, and for each of them you see a range of figures. All of those different markers correspond to slight variations in the process steps. And this goes to show that you cannot take a feedstock and take an end product electricity and say, I know that that will have saved carbon, because it all depends on what you've done along that chain. Now, the vast majority of them are well below the thresholds, but I'm making the point here that you need to be careful about all the steps along that chain. You cannot look at endpoints, and we do need to be looking at what's happening in the supply chain. This is for an energy crop, and what you find for energy crops, and indeed anything that uses land, it's the same story. Purple line is the fossil fuel equivalent, red line is the sustainability target. Lots of options. This time I've also averaged over different climate change horizons. The key thing to take away from this is the variability. You have a big, big scatter there. Some of it's great. I would love to have us sitting with bioenergy systems that are achieving those bottom lines in terms of greenhouse gas intensities, but I'm terrified of the ones at the top. So, how do we deal with uncertainty? There are different policy instruments that you can use in this, and I've heard a little bit this morning. It sounds like you're already focused in to one particular option for the RHI. But I have some work over there which is based on comparisons we have done between the UK and the German situation on the policy effectiveness of different measures. And what you find is that you've got two basic approaches. You can go for the quota system where you say, I want a certain amount of energy and I don't mind how much it costs, we'll take it in on some form of bidding or other process. Or you can go for the feed-in tariff, the fixed prices. What we found when we looked at this with people who know much more than I do about economic theory and how that side of it works, is that the most cost-effective way of delivering it is actually to go for a hybrid between those two. And it's interesting because that's what we've gravitated to in the UK. We started with a quota system and then we introduced the banding. So you either go for a hybrid that is quota with banding, or you go for a system where you have the tariffs that are set. But what is key in this is that you have flexibility built in to change and adjust as you go along. It's also key to have sustainability integrated into it. Cara's already mentioned this. I will show you something at the end. I am really, really not a fan of setting arbitrary thresholds and saying that if you don't get below that target, I'm not going to reward you at all. I'll explain why later. Sustainability is important, but I think we're framing it the wrong way at the moment. So let's have hybrid measures. You need to realise, as our previous speaker said, that bioenergy actually involves agriculture and land, and therefore it isn't enough to put these stimuli in the energy sector. You've got to look elsewhere as well and look at the wider innovation system in agriculture, in waste management, and see what we're doing there and make it all line up. I've said this with the previous graph. You cannot accurately benchmark categories of biomass resource to show what greenhouse gas intensity it will give. What you can do is you can identify practices and steps which are a good idea and which will reduce the greenhouse gas intensity of those different pathways. Okay, so I'm going to move on to the second factor that I said makes bioenergy policy complicated, and that's boundaries. Most of us are interested in that big picture thing of reducing global greenhouse gas emissions. That's the driver for a lot of this. And therefore, the policy objective should really be to maximise the greenhouse gas reductions. What you find tends to happen is when you translate that down, you will get an individual government department, Energy and Climate Change, setting their target, and they will put legislation in place that has to be fair. It has to treat different systems the same, and therefore they tend to up in a tunnel vision approach where they go down this supply chain accounting and try to compare things with each other in a very standardised way. That's fine if the tunnel vision that you've selected is one that just happens to neatly coincide with your big policy objective. Unfortunately, what we have at the moment in the UK doesn't do that, and I'm going to show you a little bit about the real greenhouse gas emissions in a moment. The reality is that when you do that calculation, you make a whole load of assumptions about the scope that you're looking at and the way you do the calculation, which actually equate to asking a very slightly different question. So, here are two ways of framing the question. One says, I've got a unit of biomass, and I want to know how much greenhouse gas reductions it will give me. Those are the figures on the left. And the second one says, I want to get the maximum reduction in greenhouse gases from the energy system compared to the energy system I'm using today. What you will see is that different bioenergy systems perform quite differently in terms of rank ordering against those different questions. I have some further information on this over in a printout which we have around the corner. It's quite fascinating. You've got to get the question right, and at the moment the question that we are asking via the RO is not the question that lines up with getting a reduction in the UK's greenhouse gas emissions in line with our Kyoto Protocol. Land interfaces, I'm going to touch lightly on this because it's already been mentioned by the previous speaker, that land is a really, really significant source of greenhouse gases, and how we integrate that along with our energy system needs careful thought when it comes to policy. Interfaces with other systems. This is a model we run for the UK looking at sustainable biomass resource going forward, excluding imports. Each column is the resource for 2010, 2030, 2015, 2030, 2020, 2030 and 2050, okay? So it's increasing as you go out. But I've got four very different scenarios there. They are not about the energy system. They are about what's happening in terms of UK GDP, UK diet, UK food production, UK levels of food security. And if I change all those other things, which are absolutely nothing to do with energy, then I end up with a very different biomass resource projection. So we need to be holistic on this. We need to therefore look at policy instruments that actually reach the things that we're trying to drive, rather than just focusing on the energy system, and counterfactuals and what we would have done otherwise are really important. In agriculture, this is key. What would the farmer have done with his land if he didn't do the bioenergy thing? That drives the biggest difference in that report that I've shown you for the Department of Energy Climate Change compared to anything else. And you can't legislate for what someone would have done, or can you? You could target particular types of practices. You could target particular types of farm, particular sizes, and perhaps only make the incentive available to them, or make it available to them at a different level, but it needs a bit of thought. Temporal aspects. This has been something that has been raised massively by the NGOs in recent years. I'm not going to say too much about it. We've got a lot of work going on in this. I'll come back with a conclusion on it, well, a suggestion to you. It's all about whether we are releasing the same or similar amounts of carbon to the rate that we are sequestering them through plant growth. I'll come back to that one. And this is somewhat similar, biogenic and fossil carbon. You hear particularly a lot of the American NGOs saying that whether it's biogenic or not doesn't much matter. It's still carbon being released, it still counts, and we've still got to worry about it. Is that true or false? Okay, here's my suggestions. Uncertainty. First, we've got to address those gaps. Every time we do life cycle assessment and we get these different numbers, we should be flagging up why we're getting them different, what the uncertainty is, and sorting them out. So I do at the moment have people at Rothamsted Research sitting with lots of piles of wood chips trying to address that one that I showed you earlier, because I think it's really important. So where we have those issues, we need to put funding into sorting it out and putting it to bed. We need to be implementing hybrid instruments. So that is this mixture of quotas and price benchmarking in order to get the most cost-effective reduction so that we don't cost too much to the consumer. You need to regularly review the policy mechanism and look at the commitment constraints. Boundaries, be really clear on objectives. If you are trying to get a 90% reduction in greenhouse gases, that is where you need to focus your policy. That is not the same thing as saying I'm trying to reduce my carbon intensity to below a certain level. We need to be really careful about this and think about the repercussions in other sectors. I cannot see why we think it's a good idea to say we're treating all renewable energy the same, or even that we're only going to pay below a certain threshold. Climate change is such an urgent issue that I personally value every unit of carbon reduction I can get. And if I get a unit, then I'll say thank you very much for that unit and I'll willingly pay for it. I don't want anybody to say I'm only going to pay for it if it goes below 40% reduction or 45 or whatever arbitrary figure someone in Whitehall has thought up. I think we should be counting it, we should be valuing it, and we should be rewarding the extent of reduction. At the moment, we are incentivizing mediocrity. We're saying that if you get to 60%, that's good enough. Don't worry if you can't do more than that. You know, you could be doing 70, but I'm not going to reward you for that, so don't bother. I think that we need to be careful. The LCA stuff is complicated. It's round the corner. I'll happily talk to anyone about greenhouse gas balances for most of the afternoon. I do leave at about 5 this afternoon. But we need to combine that with the right legislative standards and also take that big picture helicopter view to check what's going on with agriculture and elsewhere. On the land side, we need to target the worst practices. So if our counterfactual is off-gas grid, we need to look at that. You have to remember that having low carbon intensity energy is not good in its own right if you're trying to get reductions. Because you're still adding to the energy burden, you're still adding to the greenhouse gas burden. It's only good if you're actually displacing some of the high carbon stuff that you've already got. Interfaces. Be aware that reductions may manifest in other systems. This has been mentioned. The LULUCF rules mean that things can end up in strange places. You may see your reduction doesn't appear in energy. Oh dear, it appears in agriculture. It appears in waste management. It appears somewhere else. I think we're just about at the end. Timing. To the people who say, is it a problem that we are now releasing the carbon dioxide that we only sequestered 5 years ago? Well, you know what? We should have thought about this a bit sooner, really. This problem's been around for 150 years. We recognised it in 1990. And the timing wouldn't be an issue. The fact that we are releasing stuff from trees that were planted 40 years ago would not be an issue if we still had 30 to 40 years to play with. The reality is, on a climate, and I'll happily talk cumulative emissions to anyone who wants to come to our stand, but on the climate framing, we've only got about 10 years left to sort this out. If we're having this conversation in 2025, we're too late. So it shouldn't be an issue. The reality as it now is, I do have work ongoing, which is trying to address that. Come and talk to me about it. But you mentioned afforestation. Additionality is good here, rather than looking at displacement. I've mentioned this already. Low carbon energy, great idea. Not the same thing as reducing greenhouse gases. So I have a lot of information on here, the website for the hub which we lead. We have a lot of the documents there that underpin some of this stuff. You can email me direct, but we are standing around the corner at the hub stand until late this afternoon. We have loads of information we'd just love to give you, and I think there's a lot that we've learned in the UK that is very relevant to some of the work that you're doing at the moment with the RHI and other areas. So thank you.